In this video, we'll continue working with properties and graphs of quadratic function. Let's consider the following quadratic function given in the vertex form. We need to identify the vertex, axis of symmetry, opening, and range. After that, we need to graph the function and observe how the a value influences the shape. In the previous video, we learned how to rate the coordinates of the vertex of the parabola given by the formula like this. Remember, the first coordinate of the vertex is the opposite number to the one that we see inside the bracket, and the second coordinate of the vertex is the same number as we see outside of the function. So in this case, the vertex is 3, 1. If we already have the vertex, axis of symmetry of our future parabola is the vertical line coming through the vertex, so its equation must be x equals 3. We recognize opening of our future parabola just by looking at the leading coefficient. If it is positive, the opening is up, and if it would be negative, the opening would be down. The range of the parabola is connected with the vertex and opening. If the parabola goes up, that means if it has shape like this, the interval describing range starts from the second coordinate of the vertex, that means from 1, and goes till infinity, right? Like this. And finally, the shape of this parabola is the same as the shape of 1/2 x squared. It is just shifted, so the new vertex starts from the point 3, 1. Okay, so we're ready to plot. 3, 1 is here, right? The parabola opens up, so somehow like this, and its shape is of 1/2 x squared. So normally for the basic parabola, we go 1 across, 1 up, but since this value will be multiplied by the coefficient 1/2, we go 1 across and just half up. So those are the 2 points. Secondly, if we go 2 steps across from the vertex, normally in the basic parabola, we would go 4 steps up, but since we need to multiply this value by 1/2, we really go 2 steps up in our case, right? So those are the 5 points that our parabola will be shaped by. Okay, let's connect those points. Here it is. Let's see another example. What kind of information we can derive from this formula? Well, the vertex is opposite to whatever we see inside and the same number as we see outside. So it's -3, -2. Okay, we can already plot this vertex. -3 is here, -2. So that's the point. Since we already have the vertex, axis of symmetry is the line that passes through the vertex, so its equation is x equals to the first coordinate of the vertex. Since the leading coefficient is positive, the parabola opens up. And the range, similarly as before, starts from the second coordinate of the vertex and goes up. That means from -2 to infinity, like this. The shape is the same as that of 2x squared. Okay, so let's see the 5 points. We start with the vertex, we go up, and if we go 1 across from the vertex, normally we would go just 1 step up, but since our parabola is multiplied by 2, we'll need to go 2 steps up. So those are the 2 points. And the other 2 points, we go 2 across, normally will be 4 up, but now it's twice 4, so it's 8 up. It will land here. And the same to the left, over there. Okay, we have our 5 points, let's connect them. Here's our parabola. So as you see, if we know how to rate all this information from the vertex form, we can graph any parabola really quickly. Let's see this example. Here, the leading coefficient is negative, so our opening will be down. But as usual, let's start with the vertex. So how do we read the vertex again? Opposite to whatever we see in the bracket, so it's -1. And then second coordinate is the same number as we see outside, so it's -1, 2. Here's our vertex, we can plot it. -1, 2 is here. Okay. Axis of symmetry That's a vertical line passing through the vertex, so it has equation x equals to the first coordinate of the vertex. X equals -1 then. The parabola opens down this time because the leading coefficient is negative. So down. To find the range, let's picture out that the parabola goes like this. Therefore, the range is from -infinity until the second coordinate of the vertex. So it is -infinity till 2 with 2, of course. The shape is that of -1/3 x squared. And let's plot our 5 points, starting from the vertex. One across normally will go one step down, but since we need to multiply this value by 1/3, we'll go just 1/3 step down, approximately here and there. Then, if we go 2 across, normally it will be 4 down, but if we multiply 4 by 1/3, that becomes 4/3. So 1 1/3, somewhere here, and 2 across to the other side, 1 1/3 of a step down. Since we see that the parabola is pretty wide here, let's check maybe one more point. If we go 3 across, 3 squares 9, we would normally go 9 steps down, but since we're taking 1/3 of it, it will be 3 steps down. So that's the next point. And here, 3 across, 3 steps down. Let's connect those points. That's our parabola. Obviously, these arms continue farther down. And the last example, this time I wish you will stop this video and try to finish this question on your own. So we have the coordinates of the vertex are 2, 4. Axis of symmetry is x equals 2. The parabola opens down. The range is, similarly as in the previous case, from -infinity until the second coordinate of the vertex, so it's until 4. The shape is that of -3x squared, and we can start graphing it. 2, 4 is here. The parabola goes down, so one step across. Instead of 1 down, we go 3 steps down over here. 2 steps across. Instead of 4 down, we'll go 12 down. Oh, that's something that goes way beyond our grid. So we can just approximate. The other 2 points will be somewhere here. And we can connect these 3 points. The graph will be pretty narrow. Let's do it. Here it is. So we can graph parabolas nice and easy without any calculations. Thumbs up.